Mute your audio. No? So, children, today we discuss. Create mute your audio. Law of conservation of energy. Law of conservation of energy states that energy can neither be created nor destroyed, but can be changed from one form to another. Energy you can't create, you can't destroy, but can be changed from one form to another. Okay, children. So, law of conservation of energy in ninth class we have. In case of simple pendulum we have, and in case of a free falling body we have, and in case of upward thrown body you have. All those derivations I told in different videos you can check children. And also law of conservation of children, law of conservation of momentum is studied, but only law of conservation of energy is important. So in case of freely falling body also I told, in case of upward, in case of simple pendulum, I told children just give the explanation of this simple pendulum. See children, simple pendulum. Okay. So when you just pull this up like this, okay, this is highest position here, maximum potential energy. You hold it and leave it. You leave it like this, it will go. Okay. And again here maximum potential. It will stop there. Again like this, it will come and it will go. So here maximum potential energy is there. When it is coming down, all the potential energy converts into kinetic energy, and here kinetic energy will be maximum. Here maximum. This is called mean position. And these both are called extreme positions.
Extreme positions.
Okay, children. So when you are pulling to extreme position and leaving, all the potential energy decreases, kinetic energy increases, and comes. After here, kinetic energy decreases, potential energy increases, and it becomes maximum. Again, when coming, potential energy decreases, kinetic energy becomes maximum. Again, from here, kinetic energy decreases and potential energy increases. But wherever you take the total mechanical energy remains same. What is total mechanical energy? Potential energy plus kinetic
Plus
energy
kinetic energy.
is called total mechanical. Wherever you see at extreme positions, it will be full of potential energy.
Potential
At
energy.
mean position, it will be full of kinetic energy.
Kinetic energy.
And anywhere in the middle, it will be potential energy plus
Potential
kinetic energy.
energy plus kinetic energy.
So suppose children, what I mean to say, suppose here 100 joules are there. Okay, here also 100 joules only. Here also 100 joules only. And anywhere you take, it will be 100 joules only. But one form of energy will be changed into another form of energy. Like suppose here 100 joules is there, it is true, but it is potential energy which is there. All that 100 joules, the potential energy decreases and it becomes kinetic energy. And here 100 joules of kinetic energy will come. And all the kinetic energy decreases. And here again 100 joules of potential energy will come. And wherever you take in the middle, potential energy plus kinetic energy will be 100 joules. Wherever you take, it will be potential energy plus kinetic energy will be 100 joules. Okay, here if I explain, you won't understand. Among freely or upward, I will explain any one. Which one do you want, children? Any one I will explain. Which one do you want, children?
Sir, upward.
You want upward?
Upward, sir.
Okay, chalo. In upward motion, I will show you total mechanical energy remains same anywhere. I will show you how to see. This is position A, this is position B, this is position C. Okay, children. At this position, potential energy will be zero. Why? Because there is no height. Kinetic energy is whatever speed which you are throwing, that is kinetic energy. Let me say you are throwing with velocity v, then kinetic energy will be half mv square. Okay. So total mechanical energy at position A is equal to potential energy plus
Potential energy plus kinetic energy.
that is how much? 0 plus
0 plus half mv square.
so that is how much? Half mv square.
That is equal to half mv square.
At position A, half mv square. Now what I will show here also I will show half mv square only. Here also I will show half mv square. I want to show you that total kinetic energy, total potential energy, and there in the middle total mechanical energy remains same. I will show you. First, let me show you here, children. At topmost point, kinetic energy will be zero. Why? Because after going up, it will stop. And full potential energy will be there. Children. What is potential energy? mgh.
mgh.
Now, maximum height attained by the body formed is u square by 2g. Maximum height attained by the body formed is u square by 2g. Substitute this here, children. How much?
Potential energy is equal to m into g into u squared by 2g. G cancels, so m u square.
Square by 2.
So half mu square. Again, how much you got, children? Half mu
Half
square.
mu square.
Here also half mu square. Here also half mu square. But here it was kinetic energy. Here it is potential energy.
Potential energy.
In the middle, I will show you. In the middle, all of you see children. Let me say total height is h. Let me say it has gone to a height of x. When you are throwing upward at this position, x position, it has gone. Now I want at the position B, total mechanical energy at the position B is kinetic energy at B plus potential energy at B. We have to find out. If I add this both again, I will get same formula. You check children if you want. I get the same formula indicating that potential energy, kinetic energy remain same throughout the motion. Only one form keeps changing into another form. Or this is children. So first potential energy at B is formula is mgh. Okay, children, mgh, but only exit traveled. Only exit traveled. So mgx is the potential energy. Now kinetic energy, children. Kinetic energy formula is what, children? Half mv square or half mu square. And it is okay, children. Okay, now children, after going this much height, see children, okay, we know what is the formula v square minus u square is equal to 2as, you all know. Okay, initial velocity is 0 and 2 into minus g into h is how much, children? Height is how much? X.
X, sir.
Height is x. So what is the formula? V square is equal to minus 2gx. V square is equal to how much, children? Minus 2gx.
Minus 2gx.
So half into m into minus 2gx. So 2 cancel, minus 2mgx. Kinetic energy at position B is minus mgx. And potential energy, how much it is, children? Height means from the top we should take. I'm sorry, children, from the top we should take it. From the top is h minus x. Potential h minus x. Height is h minus x, children. Height it will use h minus x. Okay, always from the top we should take, children. Now you see here, mechanical energy is equal to potential energy plus kinetic energy. Potential energy, how much you got? Mgh.
Mgh minus x.
Minus mgx. And one second, oh sorry, 1 second, final velocity is 0 here. 0 square minus u square, minus gets cancelled. Here minus will go. So kinetic energy, how much you got? Mgx, children. Mgx cancel. How much you got, children? Somewhere we can draw 1 second, children. I will do that. Each and 1 second. Small mistake, children. 1 second. I forgot a daily 3D point. See, children. See, first let's do. After going here, what is the speed? Let me check that first. After going here, what is the speed? We have formula v square minus u square is equal to 2as. Okay, so what is the speed, Vincent? V square minus u square is equal to, what is the speed inside this position? See here, children. 2 into minus g into h. Here, anyone have any doubt here, children?
No, sir.
V square is equal to, this will go here, u square minus 2gh. Still here, any doubt, children?
No, sir.
Kinetic energy at position B is equal to half mv square, half into m into v square is how much, children? U square minus 2.
U square minus 2gh.
Now you see, children, half m u square minus half into half this cancel mgh. This is kinetic energy at B. This is kinetic energy at B. Now what else we want, children? After kinetic energy? Potential energy at B.
Potential energy.
What is the formula? Yeah, 1 second, children. How much height it went, children? How much height it went? X. It went.
X, sir.
So here we have to take x, children. Here we should take x because it went up to the height of x. Okay, I forgot to take. Now you see, children. And what is the potential? Potential energy always you have to measure from the ground. mgh is normal formula, but mgx because it has traveled a height of x. Now you see, children, what is total mechanical energy formula? Potential energy plus
kinetic energy.
Okay, so potential energy, how much you got, children? Mgx.
Mgx
Kinetic
plus
energy, how much you got, children?
half mu square. Mu square minus mgx.
Mgx cancel. Again, you got same formula.
Half m.
At highest position also half mu square, and at ground position also half mu square. At mean position also half mu square. Anyway, total energy is constant. I want to show, I showed you. Here also half mv square, here so half mv square, here also half mv square. But here it was only kinetic energy, here it was potential energy, here is mechanical energy. What is mechanical energy? Potential energy plus kinetic energy. What is mechanical energy? Potential energy plus kinetic energy. Here potential energy was 0, here kinetic energy was 0. So I didn't. If you practice 3-4 times, then you will understand. Okay, so freely falling bodies, one video is there, children, you can check.